Hi, Brenda here again. So, in the last video, we spent some time exploring the core pillars of trustworthy AI. We talked about things like transparency and explainability, fairness and bias mitigation, accountability, and also the importance of human oversight in AI systems. And those pillars are really important because they help organizations think about how AI systems should behave once they're deployed in the real world. But here's the thing. Before an AI system can even reach that stage, there's something much more fundamental that we need to understand, and that is data. Every AI system, whether it's a predictive model, a generative AI tool, or even an autonomous agent, depends entirely on the data used to train and operate it. The patterns a model learns, the predictions it produces, even the risks it introduces into a system, all of that ultimately comes from the data behind the model. So if the data is incomplete, inaccurate, biased, or improperly sourced, then the AI system will very likely inherit those same problems. And that's why data governance and privacy have become such critical components of modern AI governance frameworks. Organizations today need to be able to answer some very important questions. For example, where did the data come from? Was it collected responsibly? Is it accurate and reliable? And are we protecting the privacy of the individuals whose data may be included in those data sets? So in this video, we're going to focus on data governance and privacy, which really deals with the data layer of AI systems. Specifically, we'll explore three key areas that organizations need to manage carefully. First, data quality and data lineage, which help ensure that the data used in AI systems is accurate, traceable, and properly sourced. Second, privacy-enhancing technologies, which allow organizations to analyze and train AI models while still protecting sensitive personal data. And third, we'll talk about consent and intellectual property, including some of the legal questions that arise when organizations train AI models using large data sets that may contain user-generated or copyrighted material. Because at the end of the day, no matter how advanced an AI model may be, its reliability and trustworthiness ultimately depend on the data that powers it. Every AI system depends on data. In fact, you'll often hear people say that data is the fuel of artificial intelligence. And honestly, that's a pretty accurate way to think about it. Machine learning models rely on large volumes of data to learn patterns, identify relationships, and generate predictions. Without data, these systems simply wouldn't be able to function. But it's important to note that not all data is created equal. Some data sets may be incomplete, some may contain hidden biases, and others may include sensitive information that needs to be handled carefully. If organizations aren't paying attention to how their data is collected, managed, and protected, those issues can quickly turn into technical problems, ethical concerns, or even regulatory violations. So when we talk about data governance, we're really talking about the set of practices that ensure data is accurate, traceable, responsibly sourced, and properly protected throughout the AI lifecycle. In this section, we're going to focus on three key areas that are particularly important when governing data used in AI systems. First, data quality and data lineage. This involves making sure the data used to train AI models is reliable, and that organizations can trace where that data originated and how it has been processed. Second, we'll look at privacy-enhancing technologies, often referred to as PETs. These are techniques that allow organizations to analyze data or train models while still protecting individual privacy. And third, we'll explore consent and intellectual property, which deals with the legal and ethical responsibilities associated with using data, especially when that data includes personal information or copyrighted material. So with that in mind, let's start by looking at why data is considered the foundation of every AI system. Machine learning models operate by analyzing large volumes of training data. They examine that data to detect patterns, relationships, and statistical signals that can later be used to make predictions or generate recommendations. So, in a way, AI systems don't actually understand the world the way humans do. Instead, they learn patterns from the data they are given. And that creates a very important dependency. The quality of the data directly determines the quality of the AI system. If the data used to train a model is accurate, representative, and well-structured, the model is much more likely to perform reliably when it encounters new data. But if the training data contains errors, inconsistencies, or hidden biases, the AI system will almost certainly learn those flaws and reproduce them in its outputs. That's why you'll often hear a phrase used in data science and machine learning: garbage in, garbage out. Even the most advanced AI systems cannot overcome fundamentally flawed data. So when organizations talk about governing data for AI, what they're really focusing on is making sure the data that enters the system is accurate, traceable, properly sourced, and responsibly handled throughout the entire AI lifecycle. Because if the foundation of the system, the data, is unreliable, then everything built on top of it becomes unreliable as well. And this brings us to the first critical component of data governance, which is data quality. At its core, data quality simply refers to how reliable and usable a dataset is for training an AI system. In other words, can the model actually trust the information it's learning from? Because remember, machine learning models don't have intuition or common sense. They learn patterns directly from the data they're given. So if the data contains errors or inconsistencies, the model will learn those problems right along with everything else. That's why maintaining high data quality is so important. For a dataset to be useful in AI development, a few things generally need to be true. First, the data should be accurate. The information in the dataset should correctly reflect real-world conditions. If measurements are wrong or values are recorded incorrectly, the model may learn patterns that simply don't exist. Second, the dataset should be complete. There needs to be enough information for the model to identify meaningful relationships between variables. If important data points are missing, the system may struggle to learn reliable patterns. Consistency also matters. When data comes from different sources, different databases, sensors, or applications, it needs to follow standardized formats and definitions. Otherwise, the model may interpret the same type of information in different ways. And finally, the data needs to be relevant to the environment where the AI system will actually operate. Training a model on data that doesn't reflect real operational conditions can lead to poor performance once the system is deployed. Because at the end of the day, an AI model is only as reliable as the data used to train it. Maintaining strong data quality usually involves processes like data validation, cleaning, normalization, and continuous monitoring throughout the AI development lifecycle. Now, another concept that's really important in AI governance is data lineage. Data lineage simply refers to the ability to trace where data came from and how it has moved through different systems before it reaches an AI model. In other words, it answers a very practical question. Can we track the history of this data set? Think about a typical AI project inside an organization. Data might start in one place, maybe a customer database, a sensor system, or a transaction log. That data might then be exported into a data warehouse, cleaned by data engineers, transformed into a different format, and eventually used by data scientists to train a machine learning model. By the time the data reaches the model, it may have passed through several different systems and teams. Data lineage helps organizations track that entire journey. So if someone asks questions like, where did this data set originate? Who collected it? What transformations were applied to it? Or which teams modified it along the way? Data lineage makes it possible to answer those questions. And this matters a lot in real-world AI governance. For example, if a model suddenly starts producing inaccurate results, teams often need to investigate whether the issue came from changes in the data pipeline. Data lineage allows them to trace the problem back to its source. It's also extremely important for compliance and auditing, especially when organizations need to demonstrate that the data used in their AI systems was obtained legally and handled responsibly. So in practice, strong data governance means building data pipelines that are transparent and traceable, so organizations always know where their data came from and how it has been used. So once organizations understand where their data comes from and how it flows through their systems, the next major concern becomes privacy. And this is where AI governance starts to intersect with data protection laws and ethical data use. A lot of the data used in modern AI systems contains sensitive information. That could include things like personal identifiers, behavioral data, location information, financial records, or other details that can be linked back to an individual. Because of this, organizations can't simply collect and use data however they want. They have to follow privacy regulations and responsible data handling practices. One of the most well-known regulations in this space is the General Data Protection Regulation, often called GDPR, which governs how personal data is collected and processed in the European Union. Regulations like this require organizations to be transparent about how personal data is collected, why it is being used, and how it will be protected. For people entering the AI governance field, this is an important area to understand because privacy issues often appear very early in the AI lifecycle. Before a dataset is even used to train a model, teams have to evaluate questions like, does this dataset contain personal or sensitive information? Was the data collected with proper authorization? Are there risks that individuals could be identified from this data? If those questions aren't addressed properly, organizations can face serious consequences, including regulatory penalties, legal action, and loss of public trust. This is why AI governance frameworks place such strong emphasis on protecting sensitive data while still allowing organizations to develop useful AI systems. And one of the ways organizations try to balance those two goals is through something called privacy-enhancing technologies. Once organizations recognize that their datasets may contain sensitive information, the next challenge becomes pretty clear. How do you still use the data to train AI systems while protecting people's privacy? And that's exactly where privacy-enhancing technologies, often shortened to PETs, come into play. Privacy-enhancing technologies are methods that allow organizations to analyze data or train machine learning models while minimizing exposure to sensitive personal information. In other words, they help organizations strike a balance between two important goals: using data to build effective AI systems, while still protecting the privacy of individuals. One example of a PET is differential privacy. Differential privacy works by introducing carefully controlled statistical noise into a dataset, or into the results of a query. This makes it extremely difficult to identify information about any specific individual, while still preserving the overall patterns in the data that the model needs to learn from. Another approach is synthetic data. Synthetic data is artificially generated data that mimics the statistical characteristics of real data sets. It behaves like the original data from a modeling perspective, but it doesn't contain real personal records. So organizations can use synthetic data sets to train or test models without exposing actual sensitive information. There are also techniques like federated learning, where machine learning models are trained across multiple devices or servers without moving the raw data to a central location. Instead of sending the data to the model is sent to the data, and only the learned patterns are shared back. These technologies are becoming increasingly important as organizations try to innovate with AI while still meeting strict privacy requirements. For people entering the AI governance field, understanding PETs is valuable because they show how technical solutions can support responsible and compliant AI development. When organizations collect or use data to train AI systems, they need to make sure they actually have the legal and ethical right to use that data. Consent, in this context, means that individuals understand how their data is being collected and how it may be used, and that they have agreed to that use under applicable privacy laws. For example, if a company collects user data through an application, users should be informed about what data is being collected and whether that data may be used for things like analytics, service improvement, or training AI models. This is why many digital platforms include privacy policies, consent forms, and data usage disclosures. These mechanisms help ensure that individuals have visibility into how their data is being used. Organizations must not only ensure that consent was properly obtained, but they also need to keep clear records showing that the data was collected lawfully. Another closely related concept is data ownership. Data ownership refers to who has the rights to control and use a particular data set. In many cases, this can become complicated, especially when data is collected from multiple sources, third-party providers, or user-generated content platforms. For example, if a dataset contains information contributed by users, questions may arise about who has the authority to use that data for training AI models. These kinds of questions are becoming increasingly important as organizations build larger and more complex AI systems that rely on massive datasets. And that leads us to another major issue organizations must consider when using data for AI development: intellectual property rights. Intellectual property laws are designed to protect creative works and original content. This can include things like books, articles, images, music, videos, software code, and other forms of digital content. Modern AI models are often trained on very large data sets that may include publicly available material from the internet, such as text, images, or code. And some of that material may be protected by copyright or other intellectual property rights. In doing so, we have to consider certain questions. Is it legally acceptable to use that content to train an AI model? The answer isn't always straightforward, and the legal landscape is still evolving. Some organizations argue that training AI models on publicly available data falls under fair use, especially when the model is learning statistical patterns rather than reproducing the original content. However, others argue that if copyrighted material is used in training datasets without permission, it could violate the rights of the original creators. This issue has already led to major legal debates and court cases around the world, particularly in areas like generative AI, where models can produce content that resembles existing creative works. For organizations building AI systems, this means they need to be careful about where their training data comes from and whether they have the legal right to use it. Ensuring that training data complies with intellectual property rules is now a key part of responsible AI development. When you step back and look at everything we've covered, it becomes clear that data governance is really about managing the entire life cycle of the data that powers AI systems. It starts with making sure the data itself is high quality, accurate, complete, consistent, and relevant for the environment where the AI system will operate. It also involves maintaining clear data lineage, so organizations can trace where their datasets originated, how they moved through different systems, and what transformations were applied before the data was used to train a model. Then there's the responsibility of protecting privacy and sensitive information, which often requires organizations to apply techniques like privacy-enhancing technologies to reduce risks while still allowing data to be used for analysis and model development. And finally, organizations need to ensure that their data practices respect consent, ownership, and intellectual property rights, especially when training models on large data sets that may include personal information or copyrighted content. For organizations building AI systems, strong data governance is not just a technical requirement. It's also a legal, ethical, and operational responsibility. As we've seen, the effectiveness and trustworthiness of AI systems depend heavily on the data that powers them. Ensuring high data quality, maintaining clear data lineage, protecting privacy, and respecting consent and intellectual property rights are all critical components of responsible AI governance. For anyone entering the field of AI governance or AI risk management, understanding how organizations manage and govern their data is an essential skill. Now, if you found this video helpful and you're interested in continuing to learn about AI governance, AI risk management, and responsible AI practices, make sure you subscribe to the channel so you don't miss the upcoming lessons in this series. And if you're looking for structured, instructor-led training programs where you can build deeper expertise and practical skills in this field, you can visit Revecyber.com. There you'll find information about our live training programs and professional development courses designed to help individuals and organizations build strong capabilities in AI governance. Thanks for watching, and I'll see you in the next video.